Thank you, ladies and gentlemen, so much. I'm so happy you're here. I first want to thank Doug in particular, not only for the warm introduction, but especially for hosting these shindigs. I want to thank all the members and friends of the Idea Club for being here, for attending both tonight and on other occasions. As Doug mentions, this is my fourth opportunity to speak with the Idea Club. But you should know, when I told Lorna that I was going to be talking about anything at all to do with our universe, she went, and I'm trying to think of how to put this charitably, oh crap. And I said, you know, honey, the universe is a pretty big place. We ought to be able to, from that, talk about, you know, our entire Earth, ourselves, our very souls, right into our minds, our hearts, our guts, the three brains that John spoke about here last year. John's talk about our three brains had a big impact on my little brain. It made me reflect upon the fact that previously, when I've had the opportunity to speak with the Idea Club, I've kind of tried to appeal to our minds. Well, no more, not tonight. Tonight is for our guts. It's gut check time, and I say that because the question's raised. Do we know enough? Do we know enough already from where we've been together so far about our universe, our planet, ourselves, in order to change the world? And this is what I'm talking about, changing the world tonight. And I've brought with me for you tonight two answers to this question: do we know enough? Answer one, yes. And answer two, absolutely yes. Because starting tonight, our unified view, the knowledge that we already share about how and why our universe works and exists the way it does, that knowledge is going to start, if you'll pardon the pun, expanding outward, like our universe itself, and will reach the entire world. And by entire world, I do mean the 7 billion other souls currently on our planet, and I do mean by reaching them all right to the level of their innermost minds, their deepest felt hearts, and their right down to the pit of their guts. And as far as convincing you tonight that this is an achievable objective, I've made my presentation for you in three pretty small, easily digestible, fairly bite-sized chunks. Part one, dealing with the past, and logically enough, part two, the present, and part three, the future. I do want to, before we really start, point out that I've prepared my talk to fit into, without any interruptions, I can get through this, and I can get you all through this in under 50 minutes. But I don't want to do that. I wish I could have made it briefer, but there's so much that's happened and is ongoing right now, as you'll see. But I do want anybody and everybody, if there's anything crazy that I say, and that's not going to be the first time that's happened, those of you who see me speak before know, please just jump in, don't hesitate to have anything clarified. This talk isn't about me, it's about you. The mission here is to convince you that our objective is achievable. I am already on board. I want to have you with me to do it. I need you not to hesitate, jump in, any questions you have. I'm assuming that if you have a question that you've been saving up for me for for some point. We'll put that at the end. I mean, is FIDO offering a Star Trek communicator in 2 months, that kind of thing. We'll talk about that after. But if there's anything I say in the meantime that needs clarification, please, as always, regular, it's a back and forth. It's not about me. So let's begin, and as I said, to begin, I'd really like to first go back. Talk about the past for a second, not the past for our universe or our planet, but rather for ourselves, you and I, the Idea Club in particular, for hosting these meetings, and the members for attending them. Because honestly, ladies and gentlemen, speaking with you on these occasions has made a big difference, not just for me personally, but as you will see, already to an extent, we have affected the entire world. And I'm going to show you how, because part 1 of 3 tonight really is the story of how and why these meetings have already made a big difference. Starting with our first talk by me here, the Beyond Our Universe, in 2011. You know, just in the process of doing that, it forced me to really take stock of what we're fighting for here. We're, as I said that night, aiming for understanding our universe and everything within, from the size of the universe itself, there on the right down to the size of the individual atoms within our universe, and within those, right down to the subatomic realm of the size of atomic black holes. And in appreciating the wish to understand everything within our universe, we agreed that night we first have to understand not everything, but at least something about what's without of our universe, i.e. what's beyond our universe. And when we looked at it, as far as we could see with the finest Hubble Space Telescope technology available today, to the very visible boundaries of our own universe, we pretty quickly came to the conclusion that night, some of you remember, that beyond our own universe, there is in fact, between A, nothing, and B, something. We agreed almost unanimously that there's got to be something beyond our universe. And we further agreed that that something between something completely different and something more of the same had to be more of the same. And we agreed to that to a supermajority, about 67% of us. And how that became important is it allowed the rendition you see before you here of how our universe fits in to the big picture. It's the ancient Greek idea of universes upon universes. But my point in being grateful to you for these meetings is that I prepared that drawing for you that night. It was the first time I'd ever done it, and when I looked at it, I went, to this day, it's the best illustration I've seen of the big picture of our universe, and it's continued to follow me through to more talks, more applications, made a big difference. And it's just an incredible fact that you can, starting with talking with you, take this to the levels that we do and we have. I'll tell you what else that talk led to. My first YouTube video. You can see us gathered together in this very hallowed location. It led to my first use of this image that you saw that night, showing our Milky Way galaxy and the 2 satellite galaxies visible that you can see from the southern hemisphere. And you should know that I showed that image in public for the first time. It's taken by great Canadian astronomer and astrophotographer Alan Dyer. But that led to getting Alan's very generous permission to use that same incredible photograph to form the basis of my brand new website, launching very soon, within the next few weeks. And what's interesting is that my website is in fact being launched online by Douglas's son Robin, who most of you know, and to whom you have no idea how grateful I am. The fact is, as you can probably appreciate, and wishing to bring this message to the world, having a website is absolutely mandatory. This is a real difference maker for me, a game changer, honestly. And so I am incredibly grateful to Robin, to Robin's dad, Doug, to all of you. It's a fact. I'm not kidding when I say that these meetings for me have been blessed events. But that's just what came out of Talk 1. I mean, look at Talk 2, Overcoming Insurmountable Obstacles, when we talked about Edwin Hubble's discovery of the expansion of our universe, and got into the issue of there a dozen or so papers you can see up here Professional astronomers questioning Hubble's legacy. Does he deserve credit for discovering the Big Bang? Got so bad that it caused me to do research and show pretty categorically that yes, Hubble does deserve all the credit. You could, of course, say Lundmark and others discovered observational evidence. We pointed out that people like Lemaitre could be credited with discovering theoretical evidence, but it was Hubble and Hubble alone who discovered the observational proof. And that worked so well in talking with you that night that I took it on the road and wound up transforming that into my very first talk ever to professional astronomers at the American Astronomical Society meeting in Long Beach, California, just literally 2 months after presenting that to you. You can see that led to my second YouTube video. There I am presenting to the astronomers on the subject of Hubble's law, who discovered what and when. But what's important is what that ultimately led to. Those talks and a couple of papers brought a complete end to Hubble bashing. That is to say, in the last 3 years since we spoke about that, since 2011, there hasn't been a single paper questioning Hubble's legacy. That made an important difference to the world of astronomy. But something else, you know, I looked back at this the other day. I found this drawing of an alternate model of our universe. You see it on the left there, the 3-sphere, as opposed to the one we have today, the 1-sphere. And I just laughed. I mean, you know, Doug goes all the time talking about the importance of threes. So there's 3 ways. There's the far left, the far right, and the middle way, right down the middle. We shouldn't have 2-party systems, as you saw go complete the heck in a handbasket in States yesterday, and this deadlock. You need 3 parties. And, you know, seeing it so simply as I drew, pretty elementary for that meeting, after that meeting, I wound up going home with this idea, putting it into a more rigorous form, because I did the math, put it in the scale, and that wound up getting published in a paper all about this alternate model of Lemaitre's. And what goes around comes around, because it wound up coming around right back to here with you, good ladies and gentlemen, where I presented a very detailed talk on this alternate model of our universe by Lemaitre. There's the title page, but I'm showing you that because that in turn, in speaking with you, led to me going on the road again, this time to Washington, D.C., and presenting that same talk, albeit a pretty much shortened version, to the professional astronomers. You can see my best YouTube video yet. It's incredibly brief, about 12 minutes, but it describes this alternate model of Lemaitre's. And my point is, just from the meetings we've had together so far, the 3 previous, again, I don't want to harp on about me, but it's made a massive difference for my ability to understand what the heck I'm talking about. It's a bit complicated, and in trying to express it eloquently for you guys, it's really helped. But my point is, it's not about me. The fact that we brought an end to Hubble bashing, I can't overstress the importance of this. I mean, if the pinnacles of any field, Edwin Hubble, are being pilloried by its own practitioners, then it's the end of life as we know it for poor people like me who are struggling to study and practice cosmology. All of us, almost all of us, rely on public support and public funding. You just can't be out there shooting yourself in the big toe or the privates with this kind of self-bashing. And it wasn't true. As we showed, we put an end to it. That's made a big difference in astronomy. I mean a big difference, and in that way, an important difference to the world already. So that's where we've come up to the minute. But I want to show you something tonight for the very first time that I've never shown anyone, and I brought it here just for you as a pretty perfect illustration of what these meetings mean and what they lead to. I am now going to show, for the first time I've ever seen, certainly ever shown in public, exactly the mission that we are on, and you'll see pretty quickly how and why it's important. What we're attempting to do here is bring a message of peace to cosmologists and for everyone. It's a message of peace because, as we've discussed previously, you know, there's these different versions of general relativity out there, and you know, within these versions there's different variants, and you probably also know that the problem is there's a ton of cosmologists out there working, and there's not a lot of unanimity or agreement on which models or variants are right, and there's a lot of discord on whether even a whole branch of relativity is even relevant. And what we're doing by bringing Lemaitre's model back from the dead, he abandoned it himself, back from 1927 to the present, is showing cosmologists and showing ourselves, everyone here in this room and everyone here on Earth soon, that there is, as Doug says, a middle way. There is a model of general relativity originated by Lemaitre in 1927, and although abandoned, resurrected, that allows all the models of general relativity to coexist and work and play well together. That's all we're going for. And if it's a message of peace that works for the professional cosmologist and astrophysicist, it's a message of peace that's going to work for us. And I say that because if we can convince these people, shown here, professional astrophysicists, cosmologists, one of whom I'm honored to know, that's Dr. Wendy Friedman, front and center, then we are easily going to be able to convince ourselves. If the professionals agree, then it's certainly easy for the members of the Idea Club ourselves to agree amongst ourselves. Yeah, we do have the right idea. We know what's going on. We absolutely know how our universe works. It's not that hard. So it brings us back to, do we know enough? And by we, I don't mean the royal we, I mean me personally, and I mean you, each one of you individually. Do we know enough to use this knowledge to go about changing the world for the better? That's the question, to convince the professional astrophysicists and thereafter everybody, all 7 people on the planet, that we have found the middle way in understanding how and why our universe works and exists the way it does. Now, it's an ambitious goal. I can tell you there are some humbling experiences along the way. I'll give you an example right now. I'll never forget the first time I spoke here. When Doug was introducing me, he said I was somebody who had made it, and I just it kind of took me back. Okay, just not to digress or delay. I'm going to take it. I'm going to take it on the chin and say, okay, sure. And if you'll pardon the harsh terms, if you mean by made it somebody who had formerly been a high school dropout, who had hitherto not been worth a dime to anybody else working cosmology, then sure, I've made it. And I made it big time. You're looking at contractor number 64,995 for the California Institute of Technology. It's a position I am honored and privileged to fulfill to my best every day and night. It's a position that's allowed me the privilege of speaking about these big issues with you here tonight. But as far as having made it in terms of our lofty ambition to change the world, not so fast. A little distance to go, because you could say as of up to the minute, in this battle to win the hearts and minds of the entire world, we've taken our first shots. You could perhaps charitably even say we've had a couple of hits with our various talks and papers. But you should know that what we're actually talking about in this battle for the hearts and minds of the world, we're aiming for what is technically, in military terms, you'd call it air supremacy. And this differs from air superiority in the sense, air superiority, so in the global airspace, the airspace you're dealing with, you might have a competing theory, an enemy theory, a bogey theory pop up, crop up at some point, but it'd be pretty quickly shot down because you have air superiority. That's not what we're talking about. We're talking about air supremacy. There are no other enemy bogeys or competing theories. That's just it. The entire world accepts the theory that we've presented. And if that sounds lofty, I'd remind everybody that currently general relativity holds air supremacy in the world. And I know you hear about these other theories, inflation, string, brane, don't get me started, but not one of them, I mean not one, and I've studied this closely, has a single shred of observational evidence. When you deal not with theoretical physics, but actual physics, believe me when I say general relativity has complete air supremacy, in the same way that before general relativity, Newtonian mechanics held air supremacy. And that is what we are attempting to achieve. It's lofty and something else humbling on the path to success. we are like the guy shown in the arrow here, who is saying to all these other people, pretty smart guys, one holding a football and aiming for a touchdown, hey, you guys are all running in the wrong direction, because what you're looking at is a picture of a guy running a touchdown in the wrong end zone. Okay. And it's appropriate to cosmology because everybody in the field is out there looking for answers as to how our universe works. They're looking for answers ahead of them, in our future, in terms of new ideas, new physics. And what we're saying is no. I mean, the answers exist already. We have them now. They're behind us in our past. We're talking about using our knowledge of astronomical history to make new astronomical history by bringing everyone full circle based on the new observations, new knowledge, new data that we've shared a bit about, full circle back to the fact that somebody from 1927, a Belgian priest, came up with the exact right description that everybody could live well and play well and work well with together. So again, do we know enough? Let's just wrap up where we've been together so far. Thanks to these meetings, thanks to you, the answer is not only yes, but it is absolutely yes, I am convinced. It leads me to the present, and some of you who have seen me speak before might notice. Question? Anyone? Some of you may have noticed I'm a lot more confident probably tonight than you've ever seen me about our chances for this lofty ideal to come true. And there's a reason for that newfound confidence. It has to do with some big breakthroughs that have occurred since the last time we spoke here last year. Big breakthroughs, a couple of kinds. One, the great news in 2014, part one has to do with Albert Einstein himself. And the other thing that's happened is an incredible amount of observational evidence has accrued and arisen that I'll show you in more detail. But in a nutshell, on Albert Einstein, it is as though the father of general relativity and what we're talking about tonight himself rose from the grave this year, and a paper he hand wrote out, never published, threw in a drawer, completely forgot about, discovered, found, and published. All about. And what this does is lend incredible support, as you shall see, to our idea of Lemaitre's as being the one that truly does describe how and why our universe works the way it does. And on the subject of observational evidence, I'll just show you a quick example, but I mean, you can see with your own eyes pretty quickly. The true blue that you see here as opposed to the Lemaitre's, as opposed to the alternatives in red, I mean, this is what's happening, and this is why you see me pretty solidly serious about our chances for succeeding and reaching 7 billion people. And to really bring you more deeply than I ever have before into why I have this newfound confidence due to this resurrection of Einstein's ideas and this new observational evidence. I'm going to bring you more deeply than I ever have before with anyone. This will be a first into my own world, how it works, what it does. It's not as complicated as it looks. It's actually pretty elementary because all I do, as you know, I produce a database for NASA, and basically it involves looking at new astronomical papers as they're published every day, and I look at the title and I'll scan the abstract looking to see if there's anything in there that we can use. That's my whole life in a nutshell, is I'm looking at scholarly papers, I'll check the title, read the abstract, see if there's anything in there that we can use. But my point is, in doing that, in having that life, what it boils down to is I am constantly learning more about things I just don't know all about. And it's challenging because every abstract you read, that means there's something coming at you that you've either never seen before, it doesn't make sense, and you're just trying to sort of connect the dots as best you can. And it can make you feel a bit uncomfortable. It's certainly exciting. And I'm about to show you exactly what I mean. Way one of demonstrating what my world is like, I'm going to read you a scientific abstract. In fact, I'm going to read you the very abstract on the very subject that we're going to talk about further. that I will be presenting to the professional astronomers in 2 months from now. And the way that looks is title, Universe Boundary in Einstein 1931, same as Lemaitre 1927. And part of my point in showing this to you is, honestly, if I'd read that myself, and I wrote it 10, 20 years ago, I wouldn't have known what the heck Einstein 1930. Is that a date? Is it a theory? Is it a model? Is it a value? So let's take it from the top. And forgive me for reading off the page. I don't usually do this, but I just want you to see and absorb what it's like to do what I do. Here comes the abstract. Einstein and Lemaitre derived the same boundary for our universe independently. Both, therefore, may have been on the right track. Now, Einstein's unpublished 1931 dynamic equilibrium theory, only recently reported, is a hybrid theory of general relativity, incorporating both, it's a Breathman and a Candyman, dynamic, changing, and static, unchanging theories, all in one, and in its basics. It's identical to Lemaitre's 1927 dynamic equilibrium theory. Both, also reported on only recently, both dynamic equilibrium theories just happen to be based on the exact same relationship between Einstein's gravitational constant kappa, rest matter density rho, and radius r, and the same exact equation, namely 1 equals kappa rho r squared. And because dynamic equilibrium theory has finite limits, boundaries, it gives us testable and realistic estimates of the universe's age, virial radius and mass, and Hubble constant of expansion. Those estimates are 14.2 billion years in age, 14.2 billion light years in size, 9.12 times 10 to the 22 solar masses, and Hubble constant of expansion of h equals 68.7 kilometers per second, respectively. Now, abundant observational evidence, abundant, supporting those estimates means that cosmology itself might be on the verge of a revolution. Because of the relatively recent discovery of vacuum energy, cosmology could come full circle back to an old idea abandoned long ago by two of the greatest cosmologists known in history, the idea of dynamic equilibrium. Because quintessentially, a vacuum energy-filled universe in balance, changing but always steady, eternal but ever reborn, it's exactly what we observe. Now, that's the abstract, and I know that some of you, thanks to our meetings before, have absorbed a lot of it, but I also know that a bunch of it, well, what the, Ian, please, hey, buddy, seriously. And this is my world in a nutshell. A lot of stuff coming at you fast that you kind of have to try and connect the dots as best you can. But I'm going to take it another level deeper. We're going to go into My World Part 2, and that's easy as well, because now, as to what the heck that whole abstract just means, this presentation I'm going to give to the professional astronomers in 2 months, I'm actually going to give that presentation to you, ladies and gentlemen, now. And I don't mean a watered down version. I don't mean a civilized version, if you'll pardon the pun. I mean the exact version, slide for slide, word for word, what I'm going to present about these breakthroughs from the last year since we spoke last to the professional astronomers I'm about to present to you. And the reason we're doing this experiment and why I really do love you people serving as scientific guinea pigs is because I know from the experience we've had together so far that the people in this room are easily as qualified as any group of astronomers on the planet at listening to and understanding and then commenting upon exactly what we're talking about in terms of how and why our universe works the way it does. And I'm going to prove that to you right now. For the next 15 minutes, I've timed it, maybe a bit less. I'm going to be playing the part of me, speaking to the professionals in 2 months, and you will be playing the part of the professionals. Everybody ready?
Okay.
Take it from the top. Thank you, ladies and gentlemen. Welcome to Universe Boundary in Einstein 1931, same as Lemaitre 1927. We're talking about models of our universe here, and of course, in modern astronomical history, those can be traced back to the static universe of Einstein in 1917. And as we know, that was followed by the expanding universe with a few iterations. It has turned into the standard cosmological model that we have today, the Big Bang theory, shown in the middle. And I pointed out this alternate theory produced by Lemaitre in 1927, a dynamic equilibrium universe. Its interest is the fact that it incorporates both of the models you see on the left into one, and it places all of that within the confines of a black hole defined by the Schwarzschild radius. And when we do the math on these various models of our universe, it might at first look complicated, but it's actually quite simple because it's all based on the same basic equation. You can see it circled, the Schwarzschild radius of a black hole, that is Rs equals 2gm over c squared. That just happens to be the most well-known equation in all of astrophysics, except and only except for this equation, and that's it. And as promised, when I say the models are elegantly simple mathematically, I mean you can see for yourself the Schwarzschild radius, the Hubble radius, the Einstein radius, all of them. They're all basically gm over c squared and differ from each other only by these factors circled in red, and all those involve two factors, factors of pi, factors of 2, and that's it. These factors of pi, probably important in terms of our universe having spin, orbital angular momentum, as well as this radial velocity outward and inward you talk about in the regular Big Bang theory. And as promised, when we do the math, this elegantly simple math, we find the numbers behind these models, and our point in showing this is to illustrate the fact that these models of our universe are shown very accurately and in exact scale. You can demonstrate that by looking at the Schwarzschild radius on the right. You can see it is exactly double the Hubble radius, and it is exactly pi times larger than the Einstein radius. But let's just dispense with the math and the rigmarole. The main point of interest about the alternate model you see on the right here is not only, as said, does it incorporate both the expanding and the static models you see on the left in one model. What's important about it is it places an outer and an inner boundary as outer and inner limits to the expansion radius, the possible expansion radius that can be reached in the expanding universe. And why that's important? It solves two big problems with the standard model, the nothing beyond and the nothing before. So without these boundaries, for example, the standard Big Bang, all space and time is said to be included within and only within our own particular universe. That just doesn't make sense because our own universe is demonstrably finite. With this outer boundary, that's no longer a problem. The universe comes this far, no further, and that allows, by definition, space and time to continue infinitely beyond that, as they logically must. But it solves problem two, this terrible problem with the Big Bang theory, where it all exploded into existence out of absolutely nothing. Come on. I mean, that's just a violation of all the conservation laws of matter, of energy, of mass energy. Don't start. Whereas with this, we have, instead of a singular beginning for our entire universe, we just have a number of beginnings over and over again. Sure, our part of the universe had a definite start, but it was just one of many, and they repeat cyclically over and over and over again. So it is a big advance. It also allows our universe to be pictured in a much bigger picture in terms of what the ancient Greeks viewed, universes upon universes and even universes within universes. And I thought that was pretty smart, but I believe that scientists are frankly seeking more evidence. And this has been a good year for that, because you should know that this year it is as though Albert Einstein, the father of general relativity himself, rose from the grave by producing and publishing a theory that he never did publish in his own hand. But this theory happens to be, in its basics, identical to Lemaitre's alternate model. We know about this lost theory of Einstein's thanks to this man, Harry Nussbaumer, who sent me this email saying this might interest you, and he was surely right, because it was fascinating to learn that both Harry and this man, Cormac O'Rafferty, had in fact discovered this lost manuscript of Einstein's in the Einstein Archive in Jerusalem, available online, have written several papers about this, and even published a translation in English of the original manuscript. It's so important, it was noted in Nature magazine and News, Einstein's Lost Theory Uncovered. And you can see, as said, it's just a handwritten, thrown in a drawer, never published by Einstein. There it is, but you can also see, as highlighted, it is on the cosmological problem and it is written by Albert Einstein. And we can see even further that it includes a beautiful and elegant mathematical equation is highlighted here in the short time we have without getting into the terms and definitions. Let's just say the equation you're seeing says, as you can see with your own eyes, alpha squared equals kappa c squared rho over 3. And I'm saying that to make the point. It's the same equation that you're seeing reproduced here. Alpha squared equals kappa c squared rho over 3. And showing that to illustrate the fact that equation reduces through this intermediate step to the equation you see on the bottom, 1 equals kappa r squared rho. That's the same equation that Lemaitre's model is based on, as described in my paper on Lemaitre's alternate model published in 2013. It's the same equation that Lemaitre himself published. You can see written there in terms of 8 pi times, how does he put it, a squared, I think, for r squared and d for density. That is the same equation that he published in 1927 in his doctoral thesis. And this is not to be confused with what Lemaitre is really famous for, his 1927 paper written in French on the expanding universe. That really, the first Hubble constant ever calculated, by the way, by Lemaitre, that really has to do with, you can see Lemaitre's circle in the bottom here, his contribution to the Big Bang theory that we have, the standard model. No, we're talking about the model on the right here. And it is the same model on the right, the same equation found by Lemaitre and Einstein independently that leads to this elegantly, this grand simplification where we can calculate the universe's basic properties, parameters, from its size to its age to its mass to its resonant frequency, its Hubble constant, as simply as just two constants. I mean, take the top, the size, for example, c squared over g. There's some dimensional fudging you can see in brackets, but just do the math. Anybody has a calculator here now, with God and that calculator as my witness, out comes that number of centimeters and that number of light years, and that's exactly how we arrive at this. Now, there is an important difference between Lemaitre's model and Einstein's shown on the right. The difference is in Lemaitre's, you can see all the vacuum energies contained within this inner sphere here. That inner sphere does not exist in Einstein's model because Einstein has vacuum energy throughout the space. And what it's doing is vacuum energy, like quantum vacuum energy, creating new particles, new matter. It's creating new matter throughout space in exact proportion, exact counterbalance to the old matter that is escaping beyond the outer boundary due to the expansion of the universe. It's just like Hoyle's continuous creation model. But of course, we look at it now and we realize there is no matter escaping beyond the outer boundary of the universe. It's not possible, and it's a fact that Einstein abandoned this theory fairly quickly. But it's also a fact that if you look at it, Einstein's theory in its basics, the outer boundary, the expansion radius, same as Lemaitre's. The basic equation that it is based on, same as Lemaitre's. And in existing, Einstein's model lends a lot of credence and support to the idea of ours that Lemaitre's model might be more than just interesting, it could prove important to cosmology and physics. You have the model on the right compared to the model on the left. In the middle, it looks more complicated, but there is now a huge amount of observational evidence that leads us to take it more seriously. And by observational evidence, I don't just mean the coincidence between the 14.2 billion year age of the universe predicted by Lemaitre and the 13.8 billion year age you hear about based on observations all the time. That's just the tip of the iceberg. I mean, I'm talking about Lemaitre's model predicts a matter density for the universe of 1 over pi. So the total density of the universe equals 1, and the fraction of that attributed to rest matter should be 0.318, 1 over pi. And it's suspiciously close to the default value that you see physicists use all the time of 0.3. But what you may not have seen is that it just happens to be exactly the value arrived at, to within 1%, to within the margins of error, by the most accurate estimate ever of the rest matter density made by the European Space Agency's Planck mission in 2014. I mentioned last year the Hubble constant predicted by Lemaitre's model, 68.7. I did not mention same Hubble constant to, again, within 1%, within the margins of error, as the Hubble constant arrived at by Chen et al., by Calabresi et al., studying all of the Hubble constant estimates that have been published up to the years that you see shown here. It's the same Hubble constant that was arrived at in the most accurate measurement of the Hubble constant to date, thanks to NASA's WMAP mission in 2013, again, to within 1%, to within the margins of error. And finally, the biggest reason for scientists to take this alternate model of the matrix seriously is this other big problem with the current simple Big Bang picture we have, the current standard model. Not only does it suffer from the nothing beyond problem, the nothing before, the 500-pound gorilla in the room for the Big Bang model is that it predicts a non-constant Hubble constant. And if that sounds wacky, I mean, let's look for ourselves. The Friedmann-Lemaitre-Robertson-Walker model predicts that the Hubble constant of expansion in the past, the universe started expanding out at the speed of light. So it was going c kilometers per second per megaparsec, and has since slowed down to 70 kilometers per second per megaparsec we see now. So when you look back in time to the beginning of the universe, you should see a faster Hubble constant, and that's what this graph is showing. In theory, you should see at a redshift of 1, a Hubble constant of double the value measured locally, at a redshift of 2, 4 times the value measured locally. But when you show that on a linear graph showing Hubble constants on the vertical, and the radial velocity, to the extent of the visible universe, the limit is 300,000 kilometers per second, speed of light shown on the right, you can see those Hubble constants, in theory, shooting off the scale. It's even worse when you look at it in a fine scale that we actually measure Hubble constants in, plus or minus 10%. And our point in showing this is that it is not supported by the data. In fact, when you take the data, 7 indicators of the Hubble constant over the various epochs of the universe's age, shown in blue here, from right to the background radiation shown on the right, which is basically as far as you can go back in time, to the local indicators and all the ones shown in between. The universe wasn't expanding faster in the past. The simple Big Bang model isn't borne out by this. In fact, it's ruled out by this. And what's ruled in is Lemaitre's model, which predicts a constant Hubble constant. I mean, it is constant. Something else we've heard about, this idea of the expansion of the universe accelerating outward now, thanks to the discovery of the supernova. So what this is based on, you can see at that cross, a supernova at a redshift of 0.5, so 138,000 kilometers per second in velocity, are about 0.25 magnitude fainter. They appear about 10% further away than they ought to actually be. And in appearing 10% further away, they wind up reducing the Hubble constant from a default value of 70 by about 10%, by 7 down to about 63, which is exactly where that cross is. But our point is, if that trend were true, then all of these other Hubble constants would fall on that line, and they do not. The data rule out the idea that our universe's expansion rate is accelerating and going on forever to infinity. Ridiculous. The data shows that the expansion has been constant over all time, exactly what Lemaitre's model predicts. And if we were to get rid of the idea that our universe's expansion rate is accelerating, would that be so bad? Because deep in our hearts, we know this can't be right. It's exactly how Robert Kirshner described this idea of accelerating expansion, and he's one of the co-leaders of one of the 2 teams that were recognized by the Nobel Prize for the discovery of vacuum energy. So we are talking about using our astronomical history to make astronomical history by bringing scientists full circle back to the awareness of the fact that the model on the right, okay, sure, it is more complicated at first glance than the model that we have today shown in the middle, but it might be less complicated to live with in the long run, because it allows us to do 3 things that we can't with today's simple Big Bang model. It allows us to account for anything at all beyond our own universe. It allows us to account for anything at all before the Big Bang and our own particular cycle of this universe. And it allows us to account for the fact that the Hubble constant is in fact a constant as originally theorized and as clearly demonstrated by the observational evidence. So it is precisely thanks to this newest observational evidence and Einstein's newfound theory that we are led to assert that it is Lemaitre's model on the right that will prove in the long run to be more important to our astronomical history than the simple model that we have today that you see in the middle. And that's our point. Thank you, ladies and gentlemen. So I didn't time that. I hope it was about 12, 13 minutes or so. But that is what we're taking on the road, and now we've tried it on you. And this is exactly why you see me brimming with more confidence than you ever have before about bringing this idea from 1927 and an old Belgian priest to the world beyond and at large. Which leads me, honestly, to where does this go from here? What is the future of this subject? And by future, I don't mean we've all got to start sitting here now waiting for the 24th and a half century in Star Trek to happen. By future, I mean literally from this second, starting tonight and tomorrow morning and every day thereafter. That's the future I'm talking about. And it's the future I'm talking about because I guess where the rubber meets the road, what we want to know, how does this knowledge that I'm insisting we now have enough of, how does this affect the price of eggs? How does it put food on our table? How does it help support a roof over our head? How can we ourselves use this knowledge to improve and better our lives, to improve and better our world? And one of the answers I brought with me for you tonight regarding that is a paper just published June of this year, really caught my eye, titled The Practical Applications of Cosmology, of what we're talking about, to human society. And this really, I couldn't believe it. It talks about, Eric Chasen here, talks about these optimal energies flowing through everything, flowing through galaxies, our universe, life forms, humans like us. And he says they're not specific ideal values of energies, but rather the ranges of energy. Ranges that below which systems are starved and above which systems are destroyed. And this sounds exactly like the outer and inner boundary of our universe, which is also a system, described by Lemaitre's limit. I just love this paper. And the practical applications of this knowledge to human society that Jason refers to, and he wrote these, not I, he says this knowledge can impact some pretty serious 21st century problems that we face, like global warming, smart machines, world economics, even cancer research. Now, in the time we have remaining tonight, I can almost guarantee we're not going to be able to solve these problems. But I do want to leave you with some solutions that we can start using right now. I want to talk for a minute about the conclusions that we can take away for us. What's the takeaway? What's the message that we can go forth from here with tonight and really make a difference to ourselves based on this knowledge that we all now share about how our universe works? And the first most obvious one, as intelligent, sentient beings, it behooves all of us to remember to stay abreast of, as opposed to ahead of ourselves. And we know this because it's a fact. No one learns anything ever the first time. I mean, you'd think, you know, don't touch fire, don't stick your finger in that candle. That would be once you'd be done, but it's not. People get burned again all their lives. In fact, it's proof, so is our cosmology, that we don't learn anything at all that isn't learned by doing it again and again and again by repetition. And we know this thanks to Hubble. The example we mentioned earlier, Hubble didn't just discover observational proof for expansion out of the blue. He discovered observational proof for expansion by doing a bigger and better version, a repeat, but a better repeat of exactly the theoretical work that Lemaitre had done before, of exactly the observational work that Lundmark had done before. Look at Lemaitre's idea itself that we are taking to heart. I mean, that wasn't discovered by Lemaitre. It was discovered by Lemaitre and then thrown out, abandoned, only to be rediscovered by us, lo, these nearly 90 years later. The heliocentric theory, that wasn't discovered in the Copernican revolution. I mean, it was discovered by Aristarchus. It was rediscovered. And don't even start with North America and Columbus. You know, it's proof that these old axioms, these maxims, these things that we take as essentially true or almost always true, they're not almost always true. They're absolutely true. Practice, practice, practice. The old, how do you get to Carnegie Hall? That's the answer from New Yorker. Hard work. There's no getting around it. Those are the two words. That is the answer to achieving success. There is just no getting way around it. I just find it fascinating that what we know deep in our hearts and our guts already, there is mathematical support for in cosmology that satisfies our minds. You can see this happening in our experience together and bringing this idea forward. You can see this early, kind of amateurish drawing, if you don't mind me saying so, of this model of our universe shown in a repeated, better, improved way, and here new and improved. But it's just the same thing over and over again, getting better and better and better. It's exactly what our lives are, and our universe, as a matter of fact. What we know about cosmology teaches us very fundamentally the difference between humility and ego. It teaches us that it's not about any one point of view alone. Demonstrate. So at one time, the Earth was thought to be the center of everything, and of course that just turned out to be incorrect. Later, the Sun. In fact, a couple of times later, as I just said, the Sun was thought to be the center of everything. Well, now we know that the Sun is just one of 100 billion stars in our galaxy, and so our galaxy was thought to be the center of everything. But then Edwin Hubble came along and showed that our galaxy is just one of hundreds of billions in the universe. Now, as we sit here tonight, if you go out and ask professional astronomers, and most people on the street, they will tell you that our universe is the center of everything. And of course, we know for a fact that it's not. Nothing is the center of everything. There is no one person among us, or one thing, or one entity that is the center of anything at all. It teaches us humility. That's one of the important lessons we get out of the cosmological knowledge that we now share. But the most important probably is, and we went on at length about this in our talk here last year, the importance of remembering to have order versus chaos. We know for a fact that our universe is made of and based upon boundaries, rules, that these impact and affect our lives, that our universe and our lives are made to be based on boundaries, on rules. Anybody who is parents here knows exactly what I'm talking about. And these boundaries and rules lead to law and law and order in turn leads to and equates with peace, prosperity, tranquility for all. And now that is as opposed to, you see so many examples of the world today of the exact opposite, chaos. People operating as though no holds barred, no limits, no boundaries, largesse, excess. That's not the way forward. We know for a fact that our universe is very ordered. It operates with very specific patterns. It maintains at all levels, from the size of stars like our sun to the size of atoms, these very specific patterns, the same as we have amongst ourselves. This goes throughout everything. And it's a fact that while a cluttered desk is okay, Einstein would certainly agree, and Doug can attest to the state of mind right now, a cluttered mind is not. So focus, please, everyone, in the courtroom of life, order, order, that's important. Fourth, and there's just 7 of these little takeaways, and this is one that Doug talks about a lot. It's very, very meaningful, and we kind of hit on it already, it's that important, is the certain knowledge that there is a middle way as opposed to the right way or the left way. We're talking about the Goldilocks rule, not too cold, not too hot, just right. We're talking about where our planet lives around the sun. It's in what's called the habitable zone, but the technical term for that is the Goldilocks zone, not too cold, not too hot, just right. We're talking about the middle way in the sense that Lemaitre's model from 1927 is not too all Big Bang and nothing but Big Bang all the time, and not too static and unchanging and nothing but static and unchanging all the time. It's both. It allows all the kids in the park with their theories to come together and work well and play well together. It's the middle way. And it's so important. I know that we hear Doug talk about this all, he and I talk about it all the time. But you can look in Doug's new book, latest book being submitted for publication soon, in chapter 11, it mentions the importance of going from the duality that we have today, the two-party system that worked so well in the United States yesterday, to diversity. Instead of the two parties, three parties. Instead of the simplistic duality, all current debates are liberals versus conservatives, left versus right, us versus them. No, the middle way is the better way. And we know this is not just a maxim or an axiom, it's an absolute truth, thanks to the way we now understand our universe to work and exist. Something else true. We are all almost infinitely stronger together than we are apart. We know this because every atom and every soul affects every other atom and every other soul. You should know that in the simple Big Bang model, if it does expand infinitely outward, accelerate, there could be regions out there beyond which atoms would never be able to communicate. So you could have, in effect, a situation where nothing affects anything and anything goes. No, not what's happening. Every atom affects every other atom, every soul affects every other soul. We know this from our cosmology. What it means, a couple of good things, absolutely anyone and everyone among us can make a big, big difference in our world. And by a big difference for our world, I mean by definition, not a difference that's got anything to do with just one point of view or one person's or feather in their nest. A big difference, could only be big if it was effective for everyone or for a group. That's a big difference. That's a game changer. We know that we ourselves, everything in existence, are all interconnected by these patterns we talk about, these fractal patterns, repetition all around us, again and again, all around, up, down. We see, feel, and take part in and are ourselves. Resonant frequencies, resonant wavelengths. And because of this, we can say for a fact that when you hear the axiom, the whole is greater than the sum of its parts, and you think, well, yeah, true, probably true, mostly true. No, absolutely true. And it's absolutely true. I'll mathematically prove it right now. Because look at this series of signals. Steps 1 to 8 shown in red on the left. And we're making the point that in the individual signals shown in this pyramid here, it starts with no signals at all, and then it goes in step 2 to one individual signaling to 2. Those 2 to 4, 4 to 8, 16, 32, 64 hike. And our point in showing this is that if you take all the 64 individuals in that group that just received that signal from that one individual, there they are shown in 8 circles with 8 little dots each. That group of 64 at the bottom right there. Well, instead of one individual sending those 64, all 64 can send to all other 64. And what they've just done is sent 64 times 64 in the same number of steps. They've sent 4,096 signals. That's the square of the number of individuals in that group. It means mathematically, and I was shocked, I just worked this out and I went, so the strength of numbers means that a group is as much stronger than an individual as the square of the number of people in that group. So what this means is a couple, a partnership of 2 is 4 times stronger than an individual. If you take a pair of supercomputers and hook them up together in a massively parallel processing system, they can be up to as powerful as 4 times any one individual alone. Family of 4, up to 16 times more powerful than any one individual alone. I was shocked, but I proved it in another way. Take the number of people shown on the left, 1 through 8, who know a secret, and now talk about the probability of that secret never getting out. You keep the secret to yourself. So if one person knows it, probability of that secret never getting out, 50%. But as soon as 2 people know it, the probability goes down by the square of that number, 1 over 4. So now it's down to 25%. That secret's not getting out. If 4 people know it, square again, 1 over 16. Now it's down to 6%. That secret not getting out. But the good news for us, take the opposite, the probability of the information getting out. We have this idea how our universe works. We want it to reach 7 billion people. Well, if one person knows this idea, the probability of that information getting out is only 50%. But if 4 people know that idea, it's gone up to 94, and if 8 people go it, it's 98.4, and it just shoots off the scale as more and more people get to know it the way you've seen. So this is a bit mathematical in terms of proof. Let's stick to gut check time and show you a picture so you can actually feel in your guts exactly the importance of strength in numbers. Looking at a school of fish here, look at this flock of birds, and we know in our not just our minds, in our hearts and our guts, we know for a fact if one of the individuals in this, either of these groups gets separated, there's a very low probability that they're going to survive. And in fact, if you took all of the members of these groups and somehow separated them to become suddenly all individuals, there's a very low probability that any of the members of those groups would survive. And yet we look at them here, they not only survive, they thrive because of their numbers, because of this strength in numbers. And it's just a mathematical proof, although bigger and stronger than I had suspected myself, why the whole is indeed, truly, absolutely truly, greater than the sum of its parts, and we are indeed stronger together than we are apart. It leads, when we look at the idea of signaling, between entities, life forms, how our universe works, we recognize that we are all conscious versus unconscious entities. And we know that our conscious energies are directly interconnected and interrelated with the universe's energy. And so it's a fact that we're in it. We're in it right now, and we are in it to win it. And by winning, I mean we're here to make a better world. The proof, we know our brains, our consciousnesses work with these digital-like, binary-like codes. We know that our universe works with the very same kinds of digital binary-like codes. And so we know we're all interconnected, and we know that if we wish to bring all of the power in the universe and our minds to bear on the very real problems that we do face here on planet Earth today, we're going to have to avail ourselves of this conscious energy. And the final takeaway for tonight is this: if we really want to succeed with whatever we do in the world, it's important for everyone to consider the idea of meditation versus no meditation. And we're not asking for a lot here. We're simply talking about breathe in, breathe out, not too hard. Technically, breathe in through the nose, breathe out through the mouth, over and over again. We're only asking for 5 minutes a day, not too much to ask. Frankly, people spend 24/7 doing everything and all that they can for everyone else. It's unbelievable to me that more people don't take just 5 minutes for themselves and themselves only, because trust me, when you do this, when you take this conscious energy and focus the way this breathing exercise causes, it will rejuvenate your spirit and your mind in the same way that sleeping every night rejuvenates your body. You need to do this to harness these energies and have success in whatever you're doing, however you want to better the world. This could not be more important. Do it for 42 days, and my hand to heaven, you will notice a massive difference after 6 weeks in your spiritual energy, your mental acumen, and your physical stamina. Promise. Now, I know a lot of you say, I hear this all the time, gosh, I don't want to get into yoga positions or tantric stuff, or, you know, just sit down. It's not rocket science. Hands on your lap, anywhere you want them, and breathe in through the nose, out through the mouth, in through the nose, out through the mouth. Something you can add to that, because I know your minds want, I'm the worst offender. I read in the Bhagavad Gita the way to, the yogis get around that mental wandering. So when you're focusing on this breathing in and breathing out, do a little recreation of how the universe works, this cycle of expanding out, contracting in, expanding out, contracting in. So picture that as your air, breathing in, breathing out, breathing in, breathing out. And what the Bhagavad Gita says is, so take on the top of the circle your breath coming in at a high velocity, but then slow that, slow that, slow that until there's no breath coming in, no breath going out. And then start to breathe out slowly, slowly, faster, faster. Breathe out, breathe out, breathe out. Then slow that breathing out till there's no breath in, no breath out. And then breathe in again, slowly, slowly, faster, faster, breath in, and then slow down till there's no breath in, no breath out. If you do that, listen, try it later, 3 times in a row, it will reduce your heart rate instantly, 10 beats per minute. And this is a life-altering experience. Try it for 42 days. I guarantee it'll make a difference. When you try this meditation, this is not the same as conscious prayer. This is not an opportunity to pray to heaven to fix Thelma's gout or to win the lottery or ask for a frigging thing. This is an opportunity to stop and appreciate and be thankful. First, for the fact we're even alive compared to the alternative, and second, to reflect upon this message of peace of ours. It really does apply. It's a fact that we live in a universe and within lives that are based upon and specifically created for law and order and prosperity, tranquility, and peace. That's all we're saying. So do these 7 things, and why it's important for all of us to do these 7 things, because we've got 7 billion souls to reach, and it's a fact. I'll tell you right now that until all 7 billion of the members are brothers and sisters on planet Earth right now, until they are all as dialed in to this knowledge as we are here tonight, there is no way that we as a human civilization are going to evolve to even what I would call level 1. You could call stage 1 in humanity's cosmic evolution. I'd say it involves help for humanity, H-E-L-P. It would require every human everywhere to have unfettered access, whether in Africa, Asia, Bangladesh, or where poor Yusuf Malali was shot. Access to health and happiness, 1. 2, access to education, which Malala was fighting for. 3, access to lodging. And 4, access to provisions. No starvation. That's for everyone on Earth. That is why this message of peace for cosmologists and everyone is so important. That is why you will see me repeat it to the rafters, come one, come all, come what may. It happens to be, this message of peace, the only universal knowledge that exists. Now, you're going to have to think about this amongst yourselves later, but we can discuss. There is no other universal knowledge that exists, period, full stop, other than this, that everyone on Earth can universally agree upon. So I hope you're all with me. Bless you, everyone, seriously, for being here. I love you all, and I thank you all, sincerely. Thank you.